This is Chapter 20, Testing Hypothesis about Proportions. One thing I want to make very clear right here is that when we're dealing with proportions, you will usually have a percentage in the question. If it says something like 100 students were sampled and 45% of them liked froyo, right there you have p hat. This is 45 or 0.45. So you'll be dealing with proportions. You could make a true, you could test that against a true proportion, or you could make a confidence interval for that sample proportion to find the true proportion. So scrolling down a little bit to start the talk about tests, we need to talk about the null hypothesis. The null hypothesis assumes nothing. If we know in the past that UT graduates 45% of students in a 4-year period, 45% of students graduate, well then we would assume right now that 45% of students are graduating. That would be the hypothesized value. This is often something in the past, something we know to be true or we want to believe or test to be true. So we are going to say that the true proportion, right here I'm circling parameter, the true proportion of students who graduate from UT is equal to our hypothesized value. We're going to assume that's true. It's what we've seen in the past. But then we need to have alternatives. We can choose the alternative, and this will set up the test and set up the p-value. We can have the left-sided alternative that it's less than. We can have the right-sided alternative that it's greater than. Or we can have the does not equal alternative, which would be a two-sided test. Scrolling down here a good bit, we can see how this is actually drawn out. Looking at the test, this is a two-sided test right here. As you can see, they landed at 0.17 right there. They hypothesized that it would be at 0.2. When you do a two-sided test, you need to double the p-value. If this was a less than test, the p-value right here would be 0.067. So you double it. Literally on the other side, you would mark in the same spot and shade underneath it. So by doubling it, you'd get 0.134, where I'm circling right here. Let's go through the mechanics of how to run the test. To run the test, you'll need to set up your null and alternative. That's the first step we always do. Next, you'll need to pick the correct statistical model. This chapter we'll be using a z, but when we deal with means a lot of times, or pretty much always, we'll be using the t. In the 26th chapter, we'll use chi-squared. Next, we need to run our test. We're actually going to run the test here and get the test statistic. This is our z, and it's from the model that we picked. Next, we are actually going to place it onto the graph. This goes back down here, and get the p-value. So once we place it on here, we get the p-value. This allows us to make a conclusion. Almost always, we set alpha to 0.05. Now, it doesn't have to be 0.05. We pick alpha. This is the rejection rate or the critical value for which we would reject. Alpha tells us how often we will reject. Sampling variation would cause us to reject 5% of the time, because these odd results could happen. In this instance right here with this test, we would fail to reject. There are only two things we can do in statistics as a conclusion: reject or fail to reject. If the p-value is below alpha, alpha in this instance being 0.05, which is what we would assume here, we would reject. If it's above 0.05, we would fail to reject. Now let's talk about this. We expect it to fall right here in the center. If you notice, if we fall here in the center, this makes the p-values very large, because this would happen just normally. This would not be some weird occurrence. But if we fall all the way out here, the p-values would be very small. And that would mean something's going on, that this 0.2 is wrong, because we're all the way over here at 0.25, where I'm mousing over right now. And that would be a very odd occurrence, something that we wouldn't expect to see just by natural sampling variation. So we would reject the null, saying, well, I don't think that it's equal to 0.20. Something else must be going on here. It's most likely not equal to 0.20. Rejecting the null means that you show evidence for the alternative. Make sure you get this very clear. Reject the null or fail to reject the null. Don't try to be fancy and say other words. I won't even say them here. But use those words: I reject the null or I fail to reject the null. We use these tests to try to show evidence that something's going on. We try to show that the null is wrong, or show that we have reason to believe it's wrong. We can't prove it wrong. We just try to show evidence for the alternative. This should help you out, and good luck studying.